Hello, I'm Takeshi Kyoda from Shibaura Institute of Technology in Japan. We are studying a new technology to separate hydrogen and carbon dioxide gas mixtures. Hydrogen has been attracting attention in recent years as a clean energy source, and carbon dioxide is a greenhouse gas that causes global warming. So, if it becomes possible to separate these gases, we can expect to make great progress in realizing a carbon-neutral world. We are utilizing a phenomenon called the Soret effect to separate these gases. I'll briefly explain whole topics step by step by enlarging the area. The Soret effect is a phenomenon in which the mixture is separated by a temperature gradient. Relative to the Soret effect is Fick's law of diffusion, and both are balanced to become a steady state. The theoretical equation for this separation is shown here. Since the separation effect due to the Soret effect is very small, we are trying to improve the separation efficiency by using a multistage structure. Here is a diagram that illustrates a part of a multistage structure. First, when a temperature difference is applied to the z-axis, the gas separates slightly due to the Soret effect, and the separated gas flows out from the outlets on the top and bottom of the device and moves in the y-axis direction. This mechanism is such that if this movement is repeated, the respective gases eventually accumulate in the element at both sides, and the separation is improved. We conducted experiments on a device with 22 rows and 450 steps. The problem of this model was that the separated hydrogen was thought to collide with the wall and cause remixing. Therefore, next we tried to insert the partitions inside the device to suppress the remixing of gases. Prototypes of LP and SP with different lengths were made to compare their separation performance. A temperature difference of 100 degrees Celsius is applied to the device, and the gas mixture flows through it, and separated gases with different concentrations flow out from these three outlets. The difference in concentration between the high and low concentration side outlets is evaluated as the separation concentration. Experiment shows that the separation performance of SP is higher than that of LP. This topic describes the simulation that were performed to verify the experimental results. A simplified model with 5 rows and 2 steps was used as shown in the figure, and the separation performance was compared between LP and SP. The separation concentration is evaluated as the difference in concentration between the elements at both sides of the device. The physical properties and conditions used in the analysis are listed here. These are graphs of the results. The graph on the left shows the experimental results, and the right one shows the analytical results. You can see that the separation performance of SP is higher than that of LP. And they also agree well in that the flow peak appears at 30 milliliters per minute. Looking at the distribution of hydrogen concentration inside the device, it appears that the volume occupied by the partition is larger in LP, which prevents the separation. And SP has a sufficient separation distance than LP, so we consider that the separation performance is higher than that of LP. In the next study, we plan to compare the analysis results using different analysis software and investigate the devices that can separate hydrogen more efficiently by optimizing the partition size and internal structure. The main references used in this poster are listed here. Thank you very much for your coming and seeing our poster.